My name is Anna Moreno and I am the president of the Italian chapter.
In my presentation, I will speak about the importance of conceiving the cultural heritage as a living being, the generation of information during the centuries, the use of BIM for energy performance contracting and to improve the energy performance during the lifetime of a building, what information is exchanged, when, why, and among which actor, and finally the guidelines on energy performance and BIM. The buildings are living beings and we need to take care of them during their lifetime, which lasts decades, centuries, even forever. Here are some examples of buildings that changed their use during the centuries. On the left you see a Cappuccino convent transformed in the headquarters of a state advocacy general in the middle of Rome. On the right, a rural facility transformed in a luxury home. On the left, a monastery with Roman cistern transformed in hotel with spa, and on the right, an ancient hospital transformed in a museum of medicine. In the picture, you see the magnificent autopsy room. A building may have been conceived and built in the Middle Ages, then be adapted in the Renaissance, and nowadays may need a change of use or energy requalification. But even more modern buildings that were built 20-30 years ago may need renovation. All the information that can be collected from what exists, if available, will be in analogical format, and in any case it will not directly be processable by software. Therefore, the BIM for existing building means, first of all, to collect the information in a systematic way, to verify its correspondence with the reality, and then to make informed decisions based on simulation obtainable with software. European directives on energy performance require the refurbishment of at least 3% of the state buildings, and many of these buildings are listed. It is possible in these cases to use APC if the investment can be recovered in 10 to 20 years. However, existing buildings refurbishment needs to consider different constraints such as compliance with urban planning, safety, securities, architectural barriers, restoration rules, and need to ensure the functional use of the different zones with the right lighting and comfort, and of course the reduction of natural resources. The benefits are not only the reduction of the costs for the use of natural resources, but also better health due to a better comfort, lower management costs due to the possibility of the use of BIM to monitor the HVAC systems, and above all the reduction of the maintenance costs, which has the greatest impact on the management of a building. The use of BIM for energy performance contracting is a means to build a trustful balance between the achievable saving and investment value because it is based on reliable data. The point of cloud can provide a very faithful geometrical information, while other advanced techniques can provide the exact position of the different HVAC systems. On this basis, the evaluation of different scenarios can be made and reliable computational data can be obtained through BIM 4D and BIM 5D for the evaluation of time and costs. This is very important for the owner that can make informed decisions. BIM is always important when looking at the entire life cycle, as we know that the building sector is one of the highest impact on the environment because of the continuous use of the soil, emission deriving by the material used, emission during the construction, and above all emissions during the use. Through an extended use of BIM, it's possible to reduce the impact of the built environment because we can make the refurbishment of existing building more than build ex novo. Reuse or recycling the materials or use low impact materials. Optimize the logistics in order to reduce the waste in the building site, and build and restore to obtain zero energy buildings. It has been evaluated that if we look at the entire life cycle of a building, only 5% of the cost is related to the design, 18% to the construction, while more than 70% is related to the use of building. Therefore, a small mistake in the design due to wrong assumption will be paid for the rest of the life of the building. The European Commission has published the result of an investigation that has shown that there is a huge gap between the energy performance that has been considered during the design, what has been obtained during the construction, and what is the real performance during the use. That's why it's very important to provide simulation with trustful data using BIM and have a monitoring system using digital twin to monitor the behavior of both occupants and equipment.
The reason for the energy gap is related to the management of information during the life cycle of the asset. In the left side, you see the degradation of information concerning both the geometric model, the technical data, and other general documents such as authorization documents of the asset. You can see how already today it is possible with an existing asset to give back value to information through a correct definition of the asset information requirements and exchange information requirements during the redevelopment phase. In the figure on the right, you can see how information management is constantly growing using BIM, while without BIM there is a substantial loss of information passing from one phase of the asset lifecycle to another. In the next slide, we will see which information is exchanged and among which actor during the building lifecycle. The existing condition analysis is the most important phase for the refurbishment of an existing building. Any euro spent in this phase to obtain trustful information is paid back of at least one order of magnitude during the next stage of the building lifetime, especially during the operation management. The focus in this phase is in fact on the exchange and the sharing of information among the different actors. During the existing condition analysis, it is important that the regulating authority provides the plans and eventually the history of the previous refurbishment. Besides, provide the requirements for energy performance, health and safety. The owner provides the use profile of each thermal zone, any refurbishment work done previously, the electricity bills of at least 3-5 years, the plant of the HVAC system, if existing, etc. The architect in charge collects all the information and starts to build the digital model of the asset, verify the information received, and eventually use advanced techniques such as laser scanning, thermography, etc. to build the digital model. The BIM Building Energy Model Consultant makes a first diagnosis and evaluates the energy class of the building. It can also produce a preliminary simulation of some intervention to improve the energy class of the building. The map engineers intervene to provide advice on the facility of upgrading and or revamping or substituting existing HVAC system. At this point, the architect will have all the elements to prepare the preliminary design of the refurbishment as shown in the next process. The McLemming curve on the left shows how important it is in this phase in order to reduce the time and the cost. In practice, we are moving in the beginning of the building process, the decision-making process, when we are still in a virtual world, green shape, when every variation costs a few days or hours of work instead of being obliged to stop to work to solve unpredictable problems deriving from wrong assumption, gray shape. The use of BIM will allow to achieve better results in less time and minor cost, and possibly without legal dispute, which is the red shape on the right side. During the preliminary design, the ESCO or financial institution providing the loan will have the role to make the financial evaluation of the intervention and compare with the possible achievable savings. With the use of BIM collaborative format, all the actors will contribute to find the best technical solution for the best performance and the minimum costs. Thanks to BIM and the information collected during the preliminary analysis, this process will be very interactive and fast. The main output of the developed design phase will be a more detailed refurbishment plan that will leave less room to mistakes due to incomprehension and or design errors as a consequence of interference between architectural and HVAC plans. During the technical design, all the choices will be frozen so that the financial plan will be even more detailed. The model of the refurbished asset will be enriched with all the information related to products and equipment that will be used during the construction phase. This model will be the base of the contract with the constructor. The construction phase is the most challenging. Usually, constructors are not very digitalized and they interpret the design more than executing what have been decided in the technical design phase. It is therefore important that the constructor knows how to read a BIM model, and if any modification occurs, he promptly communicated it to the owner architect in order to have a real digital twin of the building. In this phase, the role of installers is important too, as they need to provide in a digital standardized format all the information needed to manage and maintain the installed equipment, and also information on the final disposal. We know how costly is the maintenance when any information about the equipment is missing or not updated. If everything has been realized as described, the operation and management will be very smooth, as anybody involved in the management and maintenance will find all the information in the right format whenever needed, and even after years the refurbishment has been completed. What I have presented is better explained in a guideline that can be freely downloaded from the Italian Building Smart chapter website. Here is the link. This guideline can be considered the body of knowledge for the qualification on the use of BIM for energy performance that I will present later. Here are my contact, our website, and we will be happy to reply to any question later on. Bye.